We related physics to driving to emphasize the importance of being safe while driving. Okay, following braking and stopping. Following distance. A driver must maintain a safe following distance, which is ideally 3 seconds behind the vehicle in front of you. Braking distance is the approximate distance traveled before coming to a complete stop. The total stopping distance is the sum of the reaction distance and the braking distance. Factors affecting following distance is road conditions and speed. The greater your speed, the greater your following distance.
Factors affecting your braking distance. The greater your speed, the greater the braking distance is. So if you double your velocity, it's going to quadruple your braking distance. The speed of the vehicle is the main factor. The weight of the vehicle and the road conditions also affect it. The heavier your vehicle, the longer it's going to take to stop. And the road conditions, if it's icy on the roads, you're going to have less friction, so it's going to take longer. And the condition of your brakes, and then the tire conditions. Factors affecting your total stopping distance. The greater the braking distance is the greater total distance. Your braking distance takes up the majority of your total stopping distance, but your reaction time also affects it, and your velocity.
Okay. Yellow light analysis. It tells you whether to stop or go at a yellow light, and the area where you go is the go zone. Where you stop is the stop zone. And if properly designed, the stop and go zones will overlap. And although at some stoplights there is an area called the no-limit zone. Okay, the go zone is all areas where you can safely go, and it is equal to the velocity of the car multiplied by the yellow light time, subtracted by the width of the intersection. And then these are the factors of the go zone. If the yellow light time increases, then it increases the length of the go zone. Width of the intersection increases, it decreases the length of the go zone. If the speed of the car increases, it increases the length of the go zone. And braking, acceleration, and reaction time have no effect on the go zone. The stop zone includes all areas where the car can safely stop before reaching the intersection, and it is equal to the velocity of the car multiplied by the reaction time plus the square of the velocity divided by 2 times the braking acceleration. These are the factors that affect the stop zone. If the speed of the car decreases, the braking acceleration increases, or the human reaction time decreases, it all decreases the length of the go zone. If the width of the intersection or the yellow light time changes, there's no effect. In order for a yellow light to be successful, the stop and go zone must overlap. In the overlap zone, the driver has a choice whether to stop or go, and if poorly designed, the stoplight may contain the limit zone.
When going around turns, the force that keeps you on the road when driving is friction, and that force is called centrifugal force. The equation to finding that is the mass of the car multiplied by the velocity squared divided by the radius of the curve. So when there's no force or friction, the car will continue on a straight path, and the friction must be greater than or equal to the force needed. Looking closer at the aspects of turning, this graph shows the force versus curve radius. So as you can see, as the radius is wider, the amount of force needed is less, therefore you can go faster. So this graph shows a 1,000 kilogram car traveling at 30 meters per second, and so as the curve increases, the force needed decreases. And then looking more at the velocity against force, so road conditions affect friction. When it's icy or wet, the friction will be decreased, and so the velocity will need to be reduced as well. So this graph is a 1,000 kilogram car going around a 100 meter radius curve, and as you can see, as the speed increases, the amount of force needed increases as well, and so as you go slower, the amount of force that you actually get is less, so you can go around that curve. lastly the radius versus the velocity. So this is showing the car that needing 9,000 newtons of force going around, or with the car being 1,000 kilograms. And as the speed increases, the curve radius can increase as well. So this kind of shows like how the posted speed limits relate to the curve. So if the posted speed limit is like at 40, the curve can be around like between 150 to 225 meters in radius. So that shows that the speed limits like are logical with the curves that they go with.
To recap our presentation, the greater your speed, the greater your following, braking, and stopping distance are. The go, stop, overlap, and dilemma zones determine whether a driver should continue or stop at a yellow light. And friction, speed, and the curve radius work together